Hey guys, we're back. We're going to start talking about 11.6 here. I'm going to try to make this under 15 minutes. We're going to do some pausing, some starting and stopping as we go, so try to stick with me. But if you have any questions, then please let me know in our discussion board. So this is the first thing that your note starts with. It's your perpendicular postulate, which should make sense because if I have a line L and I want to make a line perpendicular to it through point P, there's only one line that exists there. There can be segments within that line, but there's only one continuous line there, because if I try to make another line through point P that's also perpendicular to L, it's going to be the exact same thing that I already have. So moving on, our first problem here that we're faced with is to construct a line parallel to line L that goes through point N. So the first thing that we would want to do to make our life easy is connect point N to your line somehow so that you can see what the relationship is. So we'd make some kind of transversal line, and we like it to not be perpendicular because it's a little bit easier to work with, so we like it to have some kind of angle there. And then what we're going to really try to do is make an angle here, measure that angle in a way, and then make that same angle up here. Because we know that this transversal can continue on forever, we can work with that. We can work with that transversal being our straight line that we reference off of. So I already kind of blew it and showed you the next screen, but if you want to pause the video right now and give this a shot, you're going to need a compass and a straight edge. That'll be all you need to do this problem. So here we are. We've got everything set up, and I'm going to go through how I did all of this so it all makes sense. I went ahead and did it before we started this problem, just so there was a little bit more done, because it's kind of difficult to do on the computer, actually. I think it's easier to do manually, but on the computer it keeps things a little bit straighter and a little bit nicer, and it's color-coded on here. So the first thing that we would want to do is use that transversal coming from, and I just went ahead and labeled this point H. And we want to make an arc that goes through the transversal and through my original line L. So we make this arc, the green arc here, so we'd set my compass on there, we'd draw the arc, and of course now that's black, so I'm going to just delete that. I'm going to delete that black arc. There we go. So once we have that, we want to keep the compass the same size, and we want to move it up to point N and draw the same sort of arc connecting the transversal line with where my hypothetical new line is going to be. Of course, you don't have this new line yet, so I can actually go ahead and, if I can grab the correct thing here, I can drag this away for the current time. So right now you should have the two arcs that match up with my green arcs right there. They should both be the exact same size. So then I move back down to the point where my green arc intersects my transversal, and I want to set my compass to the correct size to be from the transversal to the point where that arc meets. So where the arc meets the transversal to the point where the arc meets my original line, that is now the arc that I want to trace out. So once I set my compass there and I make my arc, it's slightly off of what I had previously because it's very difficult to end up in the exact same spot on the computer. But once we draw that arc, we want to again move the compass up to where the green arc intersected that transversal, and we want to make the arc going from that transversal maintaining that angle size. So of course I'm minorly off just because the computer right there, but that would be the next arc. So notice that the green and the red arc intersect on this original line, or they should intersect on that original line. I'm slightly off because of the computer. So then my new line that goes through line N to be parallel to line L is going to go through that intersection point of those two arcs. And that we can then label M, as that is my new line that is parallel to the original line L. So then our got it question here asks us, why must lines L and M be parallel with each other? So we constructed this, but they're asking us, why must this be true? So if I look at the angle created here, let's call it angle NHJ, and compare that to angle 1 that we have labeled here, those angles are going to have to be congruent because of how I constructed this. We took my compass and we made two intersection points based off of H and then the point here that we could kind of call H prime. We did the same thing up here with N and the point that we could call N prime. And because we did the exact same thing, this line going from N through that intersection is parallel to the line of H going through that intersection and makes the congruent angles, which vice versa makes those lines parallel. All right, so on problem 2 here, we're asked to construct a special quadrilateral with one pair of parallel sides. Those are going to be our lines A and B, because the quadrilateral needs to be ABYZ, where AZ is congruent to my line A here, and BY is congruent to line B. So AZ, this line will be parallel to BY, that line. So we need to start by first setting up a ray, and then we need to find out how to make these parallel, because we can't just make it look parallel, we have to prove that it's parallel. So we're going to use the same method that we used in the last problem. And if I set up line AZ, and this could actually be a ray right now, so I'm going to go ahead and re-represent this as a ray because I have yet to figure out the exact length of it. So once I figure out that exact length, I can either shorten that ray or erase the extra. And what I can do is go ahead and use the same process that we just applied. I'm going to do my green arcs first here. So I would take my compass, square it up, and from my point A, I am pretty close. So then I would mark out that arc. And of course, since I already did it in green, I'm going to delete that. And make sure that when you go to move your compass, you have a point to land on. So right now, my B isn't really labeled with a definitive point, so I'm going to drop an actual point right up there to make sure that we know where we're working from. So I need to just have pen. I had a point B and I lost it, so actually I'm going to cheat a little bit. So we have our compass set here from A to our arc. So we'll drag it up here from B now that I have point B marked, and we would make that same arc there, arcing out for B. Of course, I'm a little bit shifted now. Now from the point where my arc met my transversal, I'm going to rotate my compass and pick up my red arc here. So actually I'm pretty darn close where that intersects the line. So if I want to show this again, just to make sure you totally understand what you're doing, so I lined up from that point where it meets my transversal to the point where it goes through my original line, make that arc, then line up that angle again before you move this, move it up to the point where you run through your transversal, and again on the computer it's a little hard to land it right where you want it, slightly off. And then we'd make that arc, and right where those arcs intersect is where my new line is going to be. So right now that would be a ray. We don't know exactly how long it is, so imagine that continues on this way, just like AZ does. And the last thing that we would need to do to figure out our lengths is reset my compass square, go get the size of A or B, and then copy that down. So if I wanted the size of A, let me spin this around a little bit. I would just need to go from A out to its endpoint. I did not mean that, but we can still work with that. And bring that down over here. Of course, we have to flip it around. We're close. And see the length. So that would tell me that Z needs to be right here. And I do the same process for B, which is how I got B to be the length that it is right here. BY is the congruent length to B. And then all I have to do is connect Z to the endpoint of BY. And that would give me my special quadrilateral. So the got it problem here asks us to construct a quadrilateral ABCD where AB is congruent to CD, but AB is M and CD is 2M. And notice they don't give us anything. So you're all going to have different answers for this because you're going to determine how long M is, and then based on how long M is, that will determine obviously what 2M is. So the process that you should think about is if I have a segment and all I'm working with is a straight edge and a compass. So let's say I make a segment, that's my segment M. and I need to make a segment that is double that length, but all I have is a straight edge, not a ruler, just a straight edge and a compass. So what I could do is take my compass and actually arc out the whole distance, making M the radius of a circle. So what I've done here is shown that AB is that length M, and I'll go ahead and notate that. That's M. And therefore, when I arc out AB all the way around, I get my new line CD that has a length of 2M, since that's now my diameter compared to my radius. So from there, I can use the techniques that I've been utilizing where I set my compass to a certain length and then copy that over. I do that to bring AB into my quadrilateral. CD, I do the same thing using my compass to set the distance between them and then bring that down. I use the same technique that we learned in problem 1 to make sure that these two lines are parallel. I set up my blue arcs first, coming from my point through my transversal and my original line, then from point A through your transversal and your original line AB. Then I do my red arcs starting from point A. So again, my process for red arcs would be coming from here through that point, and then I move up coming from that transversal intersection and go through there, and where that intersects is going to show me that those have to then be parallel. I can connect AC and BD however I want because they didn't tell me any specifics about whether it's an isosceles trapezoid or anything else like that. So this would be what our shape ends up looking like. Alright, so now in problem 3 we're going to construct a line perpendicular to a given line through a given point. So the first thing we need to do actually is set up some reference points. So our reference points are going to be two locations, one out to the left and one out to the right of P, that both need to be equidistant from P, because really when we talk about perpendicular relationships it all kind of comes back to right triangles. So to do this we're going to use a compass. So we'll just take our compass, open it up to some point that we establish out here, and then we arc around, and that will give us our point equidistant over there. So what that would look like here is if I set my compass point on P and then I set point A out here, I can then arc that compass around, and that will tell me where B should end up to be equidistant. So I find B like that, and again I'm going to delete that since I already showed that with the green arc. Then the next step in my process is moving the point of your compass to A. We want to choose a new point that we can call A prime, and actually I need to notate that out here. So we're going to go further than that midpoint. So now to find my A prime, we just stretch my compass a little bit further out to my A prime point. I would make that arc, and then I'd flip it around. I bring this back down square again. Then I will flip that around and do the same thing from point B. So then I'd flip it, drag it over to B, make that arc, and the last thing that we would have to do is connect from point P up through this intersection point that we can call C. We'd connect through there, and that tells me that these are perpendicular. I could actually set up similar right triangles here and show that they are congruent to each other based off side angle side relationship. I'm not going to show the got it because we're running out of time, and it's the exact same process that we just applied. So I would ask that you pause the video and do the got it on your own. Make sure that you can do exactly what we did back here, except now you'll have a line EF, and F is going to be a point that you need to create a line perpendicular to, so you want to extend that line further beyond F. Alright, so in problem 4 we have line L given to us and point R given to us, and we're being asked to construct a line through R that is perpendicular to L. So similar to when we did the point on the line, now we have the point off of the line that we have to work with, and we can actually use a process very similar. So here's your step-by-step. I'm going to pause the video for a second and come back and explain everything that we did. So for step 1, or the span of your compass just has to be something larger than the distance between R and your line L. So we make that arc, and then we're going to label these 2 points because they will be equidistant from that perpendicular line. So keeping my compass the same size that it was, I'm going to create an arc from A, and then I'm going to create an arc from B. And then you'll end up with some new intersection point down here from those 2 arcs that we just created, and that intersection point through point R creates the line that is perpendicular to my original line L. So with that, I have 10 seconds left, so hopefully you are able to do the got it problem on your own. And if you have any other questions, comments, or concerns, please do not hesitate to ask. Keep working hard, and I'll see you guys soon.